All right, welcome back, guys. So this will be our first video lecture in this course, and hopefully by now you've watched the introductory video. Okay. Now, before I start covering some of this material, well, first let me say we only cover one section in Chapter 1, and it's 1A, and it's on logical fallacies. Okay, we'll talk more about what that is here in just a minute. I wanted to kind of give you an example of why hopefully this course will be of benefit to you. Okay. So I'm going to go ahead and start. So let's say that we've got a city, and I'm going to try to make these numbers nice for computational purposes. So let's say in this city, in some particular year, let's say we only have 100 people. Okay, so it's a small city, and it's a city the size of 100, and let's say that there were, I don't know, 2 robberies. Okay, for this particular year. So if you divide 2 by 100, that's going to give you 0.02, which is the same as 2%. Okay. So there were 2 robberies in that particular year. So let's say that, I don't know, maybe 10 years later, the city has grown to a size of 1,000, and the number of robberies has actually increased. Okay, so let's say that now it's, I'm going to go with 5. Okay, or actually, we could go with, let me change this. Let's say that there were actually 10 robberies. Okay. All right, and so that would be, let's see, 10 divided by 1,000 is going to be 0.01, and as a percentage, that would be 1%. Okay. All right, so let's say you've got somebody, maybe a politician, for example, or somebody running for office, and they claim that the number of robberies has increased. Okay, and somebody else claims that, well, no, or let's say their opponent claims that actually the number of robberies has decreased. Okay, well, they can't both be right. Okay, but many times you'll hear politicians essentially say the same opposing thing. Okay, and so the question is, well, who's right? And the answer is they both are, in a sense. Okay, so person number 1 that claims that the number of robberies has increased is correct, right? Because we've gone from 2 robberies to a total of 10. But the number of citizens has increased. Okay, so yes, the number of robberies has increased, but we're also talking about 10 times as many people. Okay, so when you look at these as percentages, or the rate of robberies, so initially the rate of robberies was 2%, now it's only 1%. So the actual percentage or rate of robberies has actually decreased. Okay, and so that's why you can have 2 people saying totally opposite things, and they can actually be both correct in a sense. And the reason is because, well, which metric are they using? Are they using the absolute number of robberies, or are they using a percentage? Okay, so hopefully things of that nature we're gonna learn to be on the lookout for, guys. We're gonna, in this course, hopefully I'm going to be able to equip you with the tools to kind of decipher things of that nature. Okay. All right, and then there's one other kind of interesting thing that I wanted to show you before we start here. This is, let's see if I can find it. This is a graphic I meant to show my class last semester, but I forgot, and I still had it up on my computer, so I thought I'd show you. And we'll actually talk about this later on. So what I have here is a graph that measures the number of storms, specifically tropical storms and hurricanes, okay, per 100 years. Okay, so over 100 years in the month, or at this particular date, September the 10th, there were approximately, well, let's see, well, not 100, but close to 100, maybe 90 something, okay? Now, what I want you to notice, though, is that this is the peak time, or the peak of hurricane season, you might say. At the end of August into September, maybe into October. And then, the earlier in the year, there are fewer tropical storms and hurricanes, and then similarly, later into the year, there are decreasing numbers of tropical storms and hurricanes. Well, the shape right here is a very familiar shape, okay? This is what we call a bell curve, or a normal curve, and we'll talk more about this later on in the semester. But what's interesting, guys, is that there are many things in the natural world that exhibit this same type of behavior, okay, that have this similar type of shape. And we'll talk about that later on. Okay, so you can kind of see that it's symmetric. It's got a peak right here in the middle, around September the 10th. And then on both sides, the number of hurricanes as we deviate from September the 10th starts to decrease or fall on the left side and then also on the right-hand side. Okay, so that's just kind of an interesting graphic that we'll be looking at later. So that's kind of a pattern that we observe in the natural world. All right, well, I'm going to get back to the notes now. Okay, so probably what I'll do is just kind of lay the groundwork in this lecture, and then I'll do a part 2 in which I do some more examples for you. Okay, so 1A is on some things that are called logical fallacies. Okay, so a logical fallacy, guys, is basically an argument that doesn't work. Okay, that has some sort of logical error in it. Okay, so we first needed to figure out or define what logic is. Well, there's a definition right here. It's the study of methods and principles of reasoning. Okay, if you say, you may have heard somebody say, oh, well, so-and-so is very logical, or they have a very logical mind. Lots of times they'll say, yeah, men typically tend to be more logical, and women, tend to be more emotional, perhaps. Okay, so all of math is built upon logic. That's the neat thing, in my opinion, about math, is that it's not open for discussion. Okay, it's not like in literature you may interpret a particular work one way and somebody else might interpret it another way, and you could both, in a sense, be correct. Well, that's not the way it is with math. Okay. There is no debating the truthfulness of axioms or theorems in math. The results of math must be, okay, because they've been proven. We're not going to get into that in this course, but all right, so let's talk about what an argument is in math. So an argument in math, guys, means something different than what it means in your everyday speech or conversation. Okay, so an argument in math is not two people fighting, okay, verbally fighting, going back and forth. An argument in math is a construction that uses a set of facts or assumptions, and we call these premises, okay, to support some kind of conclusion. Okay, so what happens is you have a set of premises that you use to justify your conclusion. And we'll look at some examples here in a minute. All right, so just like a building needs a solid foundation to stand, okay? You guys familiar with the Leaning Tower of Pisa? Pisa is a city in Italy, and it was, I can't remember when it was built, hundreds of years ago. But anyway, it's supposedly the tower from which Galileo dropped objects when he was studying gravity, okay, back in the 1600s. But anyway, it is leaning, okay? You can look it up. Some of you may have seen pictures of it. You can visit it, and it's leaning quite significantly. I should have pulled up a picture. Actually, I can do that real quick. There it is. Okay. Yeah, so look at this. Or let's look at some of these images. So you can see how significantly it's leaning, okay? And the reason for that, guys, is because it had a bad foundation. Okay, now they've done things over the years to try to keep it from falling over, because if engineers hadn't intervened, it would have fallen over long ago. But they're trying to keep it from tumbling down. Okay, so just like a building, or you can think of the Leaning Tower of Pisa, needs a solid foundation, our arguments need to have solid premises. Okay, the premises must be accurate in order to build a sound argument. Okay, so a premise is a statement at the beginning of an argument. Well, let me finish reading this. It's a statement at the beginning of an argument used to support the conclusion. Okay, so it supports the conclusion. It's like this, guys. It's like, let's say, my premise is that I studied for an exam 4 hours over the weekend. Therefore, I feel strongly, or I conclude that I'm going to make a good grade. Okay, so my premise would be that I spent all this time studying, and then my conclusion would be that I'm going to make a good grade. Okay, so my premise there seems to support my conclusion. And then the conclusion is typically the ending statement of an argument. Although I do want to point out, the order can actually be reversed. Sometimes in an argument, the conclusion will come first, and the premises will come second. Okay. And we're going to see several examples here. All right. Unfortunately, guys, many times we encounter what are called fallacious arguments or fallacies. Okay, arguments that are not sound. It's a deceptive argument in which the conclusion is not well supported by the premises. Okay, so we're going to study 10 of these. All right, so I'll give you an example right here. And there's all I'm sure there's, you can think of something similar. It says, Heather just had a fuel pump installed in her car. 48 hours later, her car will not start. Therefore, so this is the premise right here, okay, that she had a fuel pump just installed in her car. Okay, so the premise is really that she didn't do anything to her car other than change the fuel pump. Okay, and then her conclusion is that the mechanic made a mistake in installing the pump. Okay, well, is this true or not? Well, we don't know. This is not sound. Okay, this premise here doesn't necessarily support this conclusion. The mechanic may have installed the fuel pump perfectly. It's just it was a bad fuel pump. And that, believe it or not, has actually happened to me, okay, with automotive parts. It wasn't necessarily, I don't think it was a fuel pump, but it was something else. Something had failed on my car. I went out and I bought a replacement, and the problem was still occurring, and turns out it was a faulty part, okay? So when I bought another part, it worked fine. So this is an example of what we would call a false cause, okay? Just because these two things are related or seem to coincide doesn't mean that one is actually causing the other one. We'll talk more about that, okay? All right, so we're going to get started. So what I'm going to do is I'm going to kind of lay out the structure of these 10 different fallacies. And then we're going to try to look at some examples. Okay. All right, so the first one here, we're going to call it an appeal to popularity. All of these fallacies, by the way, guys, they have sometimes they're known using their Latin Latin names, okay, or they're denoted in Latin essentially, because logic really started with the Greeks, and then it was adopted by the Romans. But anyway, so that's why Latin. But okay, so appeal to popularity. So you're appealing to popularity. So this is the structure of the fallacy. So typically, many people will believe that something is true. So P here just represents something, okay, a variable, an unknown. So many people believe that something is true. So this is your premise. And then your conclusion is that, well, if many people believe that it's true, therefore it must be true, okay? Now, intuitively, I think all of you know that's not always the case, right? And here's actually an example. You can call it the bandwagon argument if you want, okay? It says agreeing with a bunch of people who are wrong makes you just as wrong, okay? So here's an example. Here's an actual ad. It says, Australia, you've made the switch. Over 1 million Australians have already tried Oral-B toothpastes. Okay, so this advertisement is trying to convince you that because there's so many Australians that are already using it, it must be great toothpaste. Okay, and down here you can see it says, GoPro, make the switch today. And guys, I'm sure you can think of many advertisements that use this appeal to popularity, right? And you'll know this is probably the most common logical fallacy that's used by companies in marketing their products, although there are others too that we'll look at. All right, so that's the first one. The second one we're going to talk about is false cause. So it says A came before B, like that example I told you about with the fuel pump. So something precedes something else, okay? So that would be your premise, and then the conclusion would be that the thing that preceded the second thing is actually causing it, and that's not always the case, okay? It says false causality, okay? It could just be a coincidence. It says coincidence illegally substituted for proof, okay? So just because two things coincide, guys, or one thing precedes something else, that doesn't mean that it's causing it. We'll see many examples of that later in this course. Okay, next one is referred to as an appeal to ignorance, okay? And this is kind of the way it goes, or this is the structure. There's no proof that something is true. That's your premise. Therefore, that something must be false, okay? And an example would be, or an example that you hear a lot is, well, there's no proof that God exists, therefore God can't exist, okay? Or another example would be, there's no proof that there was at one point in time life on Mars, therefore there could never have been life on Mars, okay? Those are logical fallacies. Just because there's not any proof for something doesn't mean that that something is necessarily not the case or false. It said failed argument to ignorance. It's called appeal to ignorance, guys, because when you're ignorant, you're not privy to certain things, okay? All right, it says just because it hasn't been proven false doesn't mean that it's true, okay? So it can also go the other way. And there's a link right here in the notes. And if you remember from the introductory video, you can watch, I put these, well, let me show you real quick if I can get to it. Now in my face-to-face classes, I show those to my students. But you guys wouldn't be able to hear the audio, so if I show you that. So just want to, if you come in here to Learning Module 1 under Chapter 1, okay, if you click, let's see, right here, these are those links, okay, so I just pasted them in this document, so you should be able to click on them and watch them, and I would recommend doing so, because they're examples This is an example of an appeal to ignorance. All right, let me get back to my notes. Okay, the next one is hasty generalization. So the word hasty means, impatient, done in a rush, or done very quickly without considering things, okay? So here's the structure of the argument. It says A and B are linked somehow. Therefore, A caused B. Now, I want to point out hasty generalization is very similar to false cause. But typically, hasty generalization with false cause, that typically, you see that when there's just one instance. Okay, so you could say, okay, well, I had pork at this restaurant last night, and now I've got food poisoning, so it had to have been the pork. Okay, that would be an example of false cause. Hasty generalization would be something like, well, I've eaten pork at this restaurant 3 or 4 times, and every single time I've gotten food poisoning. That would be that actually might not be so hasty, but you can see what I'm trying to point out there is that there's been several instances, okay, and so you generalize from that, but sometimes it's done in a hasty manner. All right, it says not enough numbers on the field to represent the whole. Okay, so in other words, what this means is there's not enough evidence to actually make that generalization. All right, the next one is called limited choice. So this is the structure. It says that, or this is the premise, P is false, or something is false. Therefore, only something else can be true. Okay. What you need to think about for this one, guys, is that there are more than 2 options. What this limited choice does is it literally does that. It limits your choices. It's like saying, well, if you're not for me, you're against me. Well, that's not true. Okay. Or this is used a lot when you argue, with your significant other. Okay, so for example, let's say, instead of going to bed at 10 o'clock, you stay up and watch the news. And so your significant other says, well, you must not want to be with me because it seems like the news was more important. Okay, that's a limited choice. Maybe that individual wanted to watch the news just because they needed some time alone. Okay, had nothing to do with not wanting to be with their partner. We'll look at some other examples with limited choice. Limited choice, guys, is basically viewing the world or viewing things as if it's just black and white. Okay, like there's no in between, there are no other options or other explanations. All right, the next one. And there's a link here. You guys have probably seen some of these Allstate Mayhem commercials. So watch this link if you can. It's a good one. This would say, it says you're either with me or against me. So anyway, this commercial here kind of evidences this limited choice. All right, and then the next one is actually also used a lot. This one actually may be used the most by marketers, and it's called the appeal to emotion. It says P or something is associated with a positive emotional response. Therefore, it's got to be true. Okay. Now let me point out, it doesn't have to be a positive emotional response. It can be a negative emotional response. And politicians use this a lot. They'll try to scare you. They'll create scenarios that seem very dire and scary and try to capture your vote that way. Okay. So they're appealing to your emotion, essentially. And advertisers do this a lot. Look at this. Let me see if I can zoom in a bit. Look at this ad right here, guys. I can remember seeing this when I was a kid, I think. So Michelin is just a brand of tire. And it says here, Michelin because so much is riding on your tires. Okay, so this is an appeal to emotion because there's a baby right here. This is essentially saying that if you care about the livelihood or the safety of your baby, then you need to make sure you get these good quality Michelin tires. Okay, so they're appealing to that emotion of love and that tendency or inclination to protect your child. That's what's happening right there. All right, let's go to the next one, personal attack. This one happens among politicians constantly. It's also, by the way, in Latin, it's referred to as ad hominem. The word hominem in Latin refers to man or person. Okay, think of human. It says, I have a problem with a person or group that's claiming something. Therefore, it must not be true. Okay, so this is the premise and this is the conclusion. That's a personal attack. Okay, just because you don't like the individual doesn't make what they say illegitimate. Okay, it says personal foul, attacked the opponent instead of his argument. Okay. All right. Circular reasoning. This is really just that. It's reasoning in a circle. Okay. It says, so this is the premise. So you state that something is true, and then you restate it in different words. Okay. So it gets restated in different words, and then your conclusion is that it's got to be true. Okay. This one sometimes is kind of tricky. I'll give you an example of this that I've heard before. Sometimes people will say, the Bible is true because it's the Word of God. Or the Bible, or it could be in reverse. Okay, well, that's circular reasoning because you're essentially saying the same thing. Okay. And there's an example right here. Another link to a snippet from a Futurama episode, okay, in which circular reasoning is used. But anyway, it says you can't use a premise for your conclusion too, and that's essentially what happens when you reason in a circle. Okay. All right. The next one is called diversion, or it's more commonly known as a red herring. You guys may hear this at some point in your life. A red herring is actually a fish, okay? So you may be wondering, well, why are they calling this argument using the term for a fish? Well, there's a link right here, okay? So watch that. It's the history of how that term came about. I don't know that anybody's actually sure how it came about, but anyway, this is the structure of it. It says P is related to Q, and I have an argument concerning Q, therefore Q must be true. It's called diversion, guys, because you're literally diverting attention. It says, what does it have to do with anything? Okay. So typically you'll have a premise, and then you'll kind of drift away from that premise, and then you'll make some conclusion. Okay, I'll give you an example real quick. Let's see. Got some examples down here. I think this is an example right here. It says, good grades are needed to get into college, and a college diploma is necessary for a good career. Therefore, attendance should count in high school grades. Okay, so this would be an example of a red herring. That's definitely an example of a red herring. Okay. because this conclusion right here, attendance should count in high school grades, this is not really supported by this premise right here. It says good grades are needed to get into college, but what does attendance have to do with that? Attendance doesn't guarantee that you're going to get into college. All right. This may be the last one. Yeah, it is. Okay, the straw man argument. It says, I have an argument concerning a distorted version of P, or a distorted version of something. Therefore, I hope that you are fooled into concluding I have an argument concerning the real version. Okay, what this is, guys, is really like distortion. Okay, you're distorting someone's argument, or you're distorting what someone is saying, and then you're making some kind of conclusion from that. Okay, like it's not correct. It's called referred to as a straw man argument. Think about the Wizard of Oz, if any of you have seen that. So there was a straw man in it, and he looked like a man, but he wasn't a real man. Okay, so he was some sort of a distortion, or what would you say? Some semblance, I guess, of a man. Okay, so basically what you're doing, guys, if you look down here, it says an argument based on misrepresentation of an opponent's position. So you're basically misrepresenting your opponent's position. And there's an example right here. All right, so we've got these two people. It says the school lunch budget must be eliminated to cut waste. And then this guy retaliates by saying this guy wants to starve our children. Okay, so this response right here is not accurate. It doesn't correspond with what this person just said. He said nothing about, he or she said nothing about starving. Okay, so his or her position, argument has been distorted. And this is done a lot in politics as well. Okay, it says this argument simply ignores a person's actual position and substitutes a distorted, exaggerated, or misrepresented version of that position. Okay, so that is a straw man, or fallacy. All right, well, I think I want to conclude this video with a few examples. And I'm going to do a part 2 video. I'll probably get that uploaded tomorrow, in which we'll look at the rest of these examples, and I may even look at a couple of homework problems with you. All right, so what we're going to do here, guys, we've got 10 fallacies, okay? And to each of these fallacies, we're going to assign the type. Okay, and we're only going to use each fallacy once. All right, so let's look at this first one. It says you don't support the president's proposition of a concrete border wall. Therefore, so this is the premise right here, because your homework is going to ask you what's the premise of the argument, what's the conclusion, and it'll also ask you why is it this type of fallacy. Okay. Anyway, you don't support the president's proposition of a concrete border wall. Therefore, you are not concerned about terrorism or illegal immigration. Okay, this is a type of limited choice, guys. Remember, with limited choice, it's like everything's kind of black and white. Okay, so it says here you don't support the president's proposition for this border wall. Well, there could be many reasons that you don't support it. Okay, maybe you don't want taxes to go up, or there could be some other reason. But the conclusion here is not supported. Okay, it's limiting the options or the choices here for why you might not support the president's border wall. Okay, it says you're not concerned about terrorism or illegal immigration. Remember, it's like saying, If you're not with me, you're against me. Okay, kind of think about that. All right. Well, we already looked at this one. Good grades are needed to get into college, and a college diploma is necessary for a good career. So that's the premise right there. Therefore, attendance should count in high school grades. Well, this conclusion is not supported by this premise, okay? And like I said before, this is an example of a red herring, I believe. All right, let's go to number 3. After getting new dishes, I started to sneeze. Okay, so this is your premise. Therefore, and sometimes guys, it won't say therefore. Therefore, I must be allergic to the new dishes. Okay, so this is an example of false cause. Like I said, just because these two things seem to coincide or one precedes the other does not mean that one is causing the other. So this one would be false cause. And notice this is just one instance, right? I also want to point out that this could have been worded in reverse. And you may see this in your homework. This could also have been presented as, I must be allergic to the new dishes because after getting them, I started to sneeze. Okay? So there, you've got the conclusion coming first and the premise coming second. All right. The fourth one. This is the fourth one. The television commercial shows two people who fall in love while wearing a certain brand of blue jeans. Okay, this is an appeal to emotion. Okay, because what they're trying to do here is associate falling in love with this particular brand of blue jeans. Think about all of those pharmaceutical advertisements, guys. Have you ever seen a single person in those commercials not look happy? They look like they're the most joyous people on the earth, okay? Let's see. So this is appeal to emotion. They're appealing to your emotion. You know, guys, think about the world that we live in. We are bombarded constantly with marketing trying to make us believe that we need something when we don't. Okay, and it could be anything. It could be a physical object, like a new car, or a bigger house, or whatever. Doesn't matter. But we are being bombarded in a sense. Okay, like we don't need those things. Those are things that we want, and a lot of the time we want them because of all these appeals to emotions. All right, let's look at this next one. It says you should brush your teeth every day because brushing your teeth is very important. Guys, this is an example of circular reasoning, because really what you're doing is you're just restating the premise and the conclusion. Okay, brushing your teeth is very important. Well, that's pretty much the same thing as you should brush your teeth every day. Okay, so you're just really restating the same thing. So this is circular reasoning. You've never really given you haven't given any reason why you should brush your teeth every day. All right. It says each of my brother's 3 dogs has fleas. So this is the premise, and then the conclusion, therefore all dogs have fleas. Okay? This is an example of hasty generalization here. Okay? So because what you're doing is you're generalizing based on just these 3 dogs. Okay? Another example of this would be when we stereotype. That is that is making hasty generalizations. Okay, when we stereotype. Didn't write that the best, but all right. It says more people have iPhones than any other smartphone. Therefore, iPhones must be superior in quality. Okay, so what's being done here is that the evidence that's being given is just the fact that iPhones are very popular. Okay, there is no substantive evidence for why they're actually superior. So this is an appeal to popularity. And guys, I would be guessing that almost the entire class has an iPhone. I actually don't, okay? I have a Samsung. Usually I ask my face-to-face students that, and I'm like the only person. And you know, I was curious about that. You know, if everybody has an iPhone, why is it that, why are Samsung phones even sold? Well, so I looked it up, and they're actually much more popular in other parts of the world, okay? It's actually closer to like 50-50. It's just, you know, here in the U.S., I suppose, it's predominantly iPhone. Okay, scientists have not found any concrete evidence of life on Mars. Therefore, there could never have been life on Mars. So I think I used this as an example previously. Okay, this would be, let's see, appeal to ignorance. Okay, because just because we don't have any proof doesn't mean that there was never life on Mars. So this is an appeal to ignorance. I'm just going to put ignorance. All right, number 9. It says, when confronted with questions from the press about alleged scandals, a congressman replies that the allegations against him should be ignored since his accuser is part of a vast right-wing conspiracy. Okay. So let me go ahead and tell you. The premise is that his accuser is part of a vast right-wing conspiracy, and the conclusion is that the allegations against him should be ignored. Okay, so this is a personal attack, essentially. He's attacking his opponent, not really giving any actual reason for why these allegations should be ignored. He's just saying that, you know, my accuser is just part of this vast right-wing conspiracy, so he's attacking him or her. All right, and then this last one. It says, suppose the mayor of a large city proposes raising taxes to better support a local community college. And then his challenger in the upcoming election says, the mayor doesn't think that there's anything wrong with taking away money from those who work hard. Well, this is a straw man fallacy here, guys, okay? Because that's not what this mayor is actually saying, okay? I'm sure he or she thinks that there's a lot of value in the money that these hard-working individuals make. Okay, so what has been done here is that this person has distorted what the mayor has actually said. So I'm going to put a straw man. Okay. All right. And I think I'll stop there for now, guys. I'll do a little part 2 in which we look at the rest of these examples, and then I'll maybe do a couple homework problems for you. Okay. Also, hopefully, I mentioned this in the introductory video, hopefully, if you're able, you're printing these notes and you're kind of following along with the lecture and filling them out so that you'll have something with which to refer whenever you're working on your homework. Okay, I can't make you do that, but that's what I would recommend. All right, in any case, guys, I'll see you in the next one.